Ladies and gentlemen, welcome to this short video looking at the energy stored in the gravitational field between the Earth and another object. We call that the gravitational potential energy. So I will use the words gravitational potential energy and energy stored in the gravitational field interchangeably. They're the same things. One thing to note, if you're looking at the energy stored in the gravitational field, then both the Earth and your object have to be inside the system. On the LOL diagrams, the circle, all the objects that are in your system are inside that circle. You have to have both the Earth and your object inside that circle for there to be any energy stored in the gravitational field. We're going to look at this skate park example where we have our skater and she's at the ground level right now. So this simulation calls the bottom of the ramp the ground level, the zero mark for our height. If I put her up the second bar, we can see that she has some potential energy due to gravity. If I put her up at the fourth bar, that energy has increased. And if I put her up the sixth bar, it has increased even more. So we can see that the gravitational energy, the energy stored in the gravitational field, is dependent upon the height of the object inside that field. Another variable that we want to look at is the mass of the skater. So if I put the skater at the 4 mark, you can see that she's got some baseline set of gravitational energy. If I lower the mass of the skater, you can see that the potential energy due to gravity has decreased. However, if I increase the mass of the object, you can see that the energy stored in the gravitational field has increased. So the mass of the skater absolutely impacts how much energy is stored in the gravitational field. The last variable that we can't really investigate is the strength of the gravitational field. If we were to take this skate park and take it up to the moon, where there is less gravitational field strength, I would imagine there would be less energy stored in that field. If we were to go to Jupiter, where there would be more gravitational field strength, I imagine there would be more energy stored in the gravitational field. And that is exactly what we see. The potential energy due to gravity is dependent on the mass of the object, the strength of the gravitational field, and the height of the object in that gravitational field. Or potential energy due to gravity is equal to mass times gravity times height, mgh. If these were my notes, I would absolutely make sure that I have this equation highlighted as the potential energy due to gravity, the energy stored in the gravitational field between the Earth and another object. Now, one thing that's really neat to notice is that you get to decide what you want to call your zero height. The skate park chose it to be at the very bottom. For this example, you can see I've got a block sliding along at points A, B, and C. And I get to choose where I want my H equals 0 to be. I've started off choosing it at the very bottom of the ramp so that at point B, the Earth block system has no energy stored in the gravitational field. And it would have energy stored at A and C, respectively. If, on the other hand, I put my H equals 0 up here, then the Earth block system has no energy in the gravitational field at points A and C, but it would have some at B. In fact, it would have negative potential energy. So we can see if we're below our H equals 0, we have a negative gravitational potential energy, and that's okay. If I put the H equals 0, I could put it way down here, in which case my Earth block system would have gravitational field energy at A, B, and C. Or I could put this H equals 0 way up here, in which case I would have negative potential energy at A, more negative energy at B, and then back to some negative energy at C. You're adult-ish. You get to decide where you want to put your H equals 0. And we'll see some examples with that on the third video today.